The working theory. Now, a ray gun creates VUV light within the gas tube. That's explaining again. VUV is a light wavelength which we cannot see. It stands for vacuum ultraviolet. It's light which can really pass through a vacuum unattenuated. If it passes through air, then the air blocks it. The bandwidth of the light is very narrow, which is between the range of 221 and 223 nanometers. And the photons from the VUV light are powerful enough to kill fungi, viruses, and cancer cells living on the skin, but it is safe. The dead skin layer on the human body almost completely absorbs VUV radiation. So VUV will not harm normal skin cells. However, VUV photons set off a chemical reaction to create nitric oxide and ozone within cells and tissues, and this works together to help various skin conditions. The nitric oxide clears bacterial, fungal, viral, and parasitic infections. Healthy cells thrive on oxygen and can't live without it. Disease-causing nasties like bacteria, fungi, parasites, and microbes are anaerobic, and they die in the presence of oxygen. So if you get oxygen in your body, all the bad guys die and all the good guys just love it. Now, ozone is a powerful activated form of oxygen. And the ozone produced kills anaerobic organisms without affecting healthy cells. Now, many of you would have heard of ozone therapy, where they take your blood, inject ozone into the blood and reintroduce it into your body. That's a very powerful therapy which addresses a great number of conditions, life-threatening conditions. Well, ray gun produces ozone. All of these combined can help get rid of skin conditions more effectively than contact mode alone. This is how you apply ray gun in arc mode. You touch the front of the tube against the skin, and you have it on an angle so that a little bit of a gap is on the other part of the tube, and ozone gets created here. Copious amounts of ozone. Now, in addition, ray gun forms a microscopic secondary ionization layer between the gas tube and the target skin. Current flows between the tube and the target. You can increase this current by placing an earthing pad on the opposite side of the target area. This increases the amount of ozone and nitric oxide, and more importantly, allows pathogen disabling compounds to travel deeper into the body to reach problem areas, all without harming healthy cells. Now, this is what we were talking about just a little bit earlier in the lab trials, through the skin. VUV cannot pass through skin. The healing effects of this MiraMate Ray Gun does pass through skin, and it goes much deeper. Now, interestingly, a study was released just last month proving that there was a way of killing the coronavirus. Now, it's really cool because it's like we've been developing this product and we're almost ready to release it, and then this report comes out saying, wow, this is a surprise. This wavelength, this magical 222, kills the coronavirus. And there's us thinking, yeah, we know that. we know that. But here we go. This is done in a formal study by the Hiroshima University Department of Public Relations. Now, the report was from the public relations, but the test was from the Hiroshima University. And the heading reads, researchers offer first proof that ultraviolet C light with a 222 nanometer wavelength, which is safer to use around humans, effectively kills the SARS-CoV-2 virus. Is it any surprise to learn that the MiraMate Ray Gun uses 222 nanometers as the wavelength? This is the first study in the world that proves its potency against the virus which causes COVID-19. Now, we didn't do the tests on COVID-19 because it's kind of a little bit dangerous, and we didn't have samples to use. So it's very good to know that as well as being effective against cancer cells and E. coli, it's also effective against the coronavirus. So let's read more about it. Well, I'll just I'll abbreviate in this report. They found that 222 nanometers, which is safer to use around humans, kills the coronavirus. And other studies have only looked as far as how good this wavelength is for seasonal coronaviruses, not specifically the coronavirus that causes the COVID-19. Now, in an in vitro experiment, that means in a dish, like the experiments that we did, the researchers showed that 99.7% of the coronavirus culture was killed after just a 30-second exposure to that light at a light intensity of 0.1 milliwatts per square centimeter. Now just keep that number in your mind, 0.1 milliwatt per square centimeter. Okay, now they used this Oshio's Kia 222 krypton chloride excimer lamp. They don't sell this lamp to the public. You may be asking, why don't they sell it to the public? Well, we don't really know. Maybe it's commercial reasons. But you cannot buy this lamp. It's also, if you do work in a research or a large industrial corporation, and you do buy this lamp, the lamp costs us in the thousands. It's not easy to create 222 nanometers. Now, they go on to say a wavelength of 222 nanometers cannot penetrate the outer non-living layer of the human eye and skin. So it can't cause harm. It can't cause blindness. It makes it a safer but equally potent alternative to the more damaging 254 nanometer UVC germicidal lamps increasingly used in disinfecting healthcare facilities. Now, this is a very important point. Ultraviolet lights that you can buy are extremely dangerous. They have mercury in them. Mercury vapor spectral range is around 254 nanometers. It's okay for killing germs, but it's also okay for killing our own cells. It's kind of dangerous. And so these kind of lamps need a lot of protection. They need to be shielded so you can't see them. You need to wear protection, gloves and other things to stop yourself from being burned. It's very, very dangerous. So our light, which is 222, is safe, and it's been proven to be safe in that report. And this is another group. This is in the Kobe University. They demonstrated a world first via animal experimentation that repeated irradiation of 222 nanometers, once again, ultraviolet radiation, to see how good it was for disinfecting surfaces. They stated it does not cause skin cancer, and it is safe for exposure to human skin and eyes. They finish off by saying this technology is expected to be utilized in a wide range of antibacterial and viral inactivation applications in the medical field, as well as many opportunities for use in daily life. Now, they repeatedly irradiated using a 222 nanometer lamp onto a group of mice. Now, these mice were very sensitive to ultraviolet, and they have a habit of developing skin cancer. They've got a 10,000 times greater chance of developing skin cancer compared to regular wild mice. So they put these poor mice underneath this 222 nanometer lamp. They found that in the control group, who were radiated with normal ultraviolet light, normal being just the 280 to 350 nanometer range, all of them developed skin cancer. And many of those mice also displayed other things with corneal injuries. That's injuries in the eye with cataracts where you can't see, you get blind. And UVB is the wavelength range within natural sunlight which causes skin cancer. So when people talk about ultraviolet, immediately you think cancer. I mean, who doesn't, right? And you have sunblock they put onto your skin to block ultraviolet light. But there's this magical 222 ultraviolet light. With these mice, no mice in the 222 nanometer germicidal lamp group developed skin cancer. Just repeating, none of them. Nor were there any abnormalities found at the microscopic level upon further analysis. And so it became clear that the reason 222 nanometer radiation caused no harm was related to the level of skin penetration. Normal UV radiation passes right through your skin to the deeper parts of your skin. It can damage the cell's DNA, but 222 nanometers only reaches the very, very top layers of the skin and causes no damage to the DNA of epidermic or living cells. This shows a very simplistic way of how they radiated the mice. You can see the UV lamp here and here. And they dissected the skin. They could see through cross-section just how deep the damage was. But VUV did not reach the lower layer of the epidermis. Now this is the light spectrum of our device. Where there's the big spike here, that's 222 nanometers. Because the unit is quite powerful, the measurement had to be measured at about 2 inches away from the lamp. Any closer, and the test instrument started getting very unhappy and decided to stop. But you can see the spectrum of the wavelength. All the damaging, all the nasty wavelength, which is past the 222, is virtually zero. Now remember I asked you to remember that number before. It was the light intensity of the VUV lamp that was used in the experiments. They used 0.1 milliwatts per square centimetre. Ray Gun's got 1 milliwatt per square centimetre. So it's certainly quite a powerful device.